The disappointment of a teenager while diving sparked the largest ocean cleanup campaign in human history. In just over a decade from that moment, a nonprofit organization has pulled more than 45 million kilograms of plastic out of oceans and rivers around the world, equivalent to nearly 100 million pounds of waste. This is no longer a symbolic or media-driven campaign, but a genuine physical effort where every kilogram of plastic is retrieved, sorted, and processed. So how did they manage not only to prevent this campaign from slowing down, but to accelerate it over time, and in doing so, push humanity's capacity for intervention into an entirely new phase? That's what we will uncover in this remarkable journey. Between Hawaii and California lies an area known as the Great Pacific Garbage Patch, a body of water covering roughly 1.6 million square kilometers, nearly twice the size of the state of Texas, or 3 times the size of France. This is not a solid, continuous, floating island of trash as many people imagine, but rather an accumulation zone where ocean currents gather plastic from all over the world. The problem is not only the amount of plastic visible to the naked eye, but the continuous fragmentation process under the effects of ultraviolet radiation, waves, and abrasion, which produces microplastics of ever smaller sizes. These microplastic particles can enter the marine food chain, be absorbed by plankton, bioaccumulate across trophic levels, and ultimately return to the human body. In ecological logic, every year of delay in cleanup means that all future intervention efforts become more complex and more costly. And humanity has delayed this process for more than 7 decades, since plastic began to be produced and exploded on a global scale in the mid-20th century. Scientists estimate that this area accounts for just 1% of the ocean's water, yet concentrates around 1.8 trillion plastic pieces, with a total mass of between 79,000 and 100,000 tons. For decades, experts have been nearly unanimous in agreeing that cleaning this area is impossible. Estimated costs run into tens of billions of US dollars, and if traditional methods such as ships and nets were used, the process could take thousands of years. In terms of scale and physics, this is a problem that exceeds the capacity of any solution ever proposed. Against this seemingly hopeless backdrop, a 16-year-old Dutch boy named Boyan Slat appeared and proved everyone wrong. In 2011, during a scuba diving trip in Greece, Slat expected to witness the Mediterranean ecosystem, but instead, what he saw more frequently than fish were floating plastic bags. They were everywhere, repeating themselves to the point of creating a disturbing distortion of the ocean's natural order. For most teenagers, that moment would likely have ended as a passing annoyance. But for Slat, it led to a very simple, even naive question. Why can't we just clean this up? That question did not fade after a few days. It stayed with him for years, gradually becoming the core of the entire journey that followed. Rather than merely protesting pollution, he began to seriously study why experts believed that cleaning the ocean was impossible. Slat analyzed costs, assessed logistics, and examined the technical limitations of traditional methods. It was precisely during this process that an idea, so simple it initially seemed absurd, began to take shape. Instead of chasing plastic across millions of square kilometers with ships and nets, why not let the ocean currents do the work? If barriers were designed intelligently enough, natural flows could concentrate the plastic for collection, eliminating the need for a massive fleet of ships consuming fuel and manpower. This was an approach that ran counter to conventional intuition, yet aligned perfectly with how the ocean itself operates. Slat went on to study aerospace engineering at Delft University of Technology in the Netherlands, where he continued to develop his idea. In the fall of 2012, he won the Top Engineering Design Award for his ocean cleanup concept. On October 5, 2012, at the age of 18, he stepped onto the TEDx Delft stage and delivered an 11-minute talk titled, "How the Oceans Can Clean Themselves."
However, I believe the Great Pacific Garbage Patch can completely clean itself.
For several months, the video received almost no attention, garnering only around 2,000 views. But in February 2013, news outlets discovered it, and the video exploded almost overnight. Donations began pouring in within days, forcing Slat to make a major decision: continue his engineering degree or drop out to pursue the goal of cleaning the ocean. At the time, he had only $300 in savings. Slat chose the ocean. Just days after the video went viral, he received $90,000 in donations, and by October 2013, when the TEDx talk surpassed 1 million views, the Ocean Cleanup was officially founded. Before calling for funding on a global scale, the newly founded organization wanted to prove that its idea could actually work. On June 3, 2014, a 528-page feasibility study conducted by around 70 scientists and engineers was published, and a crowdfunding campaign was launched simultaneously. The response exceeded all expectations. Within 100 days, 38,000 donors from 160 countries had contributed. And by September 15, 2014, the total reached $2,154,282, making it the most successful nonprofit crowdfunding campaign in history at the time. At the same time, Slat made a bold promise to clean up half of the Great Pacific Garbage Patch within 10 years, a goal that even supporters considered extremely ambitious. In August 2015, the Mega Expedition campaign was launched, with 30 vessels operating across the Pacific Garbage Patch, collecting more data than all scientific research from the previous 40 years combined. These findings quickly overturned many earlier assumptions. The garbage patch was not a solid mass, but more like a plastic soup dispersed across a vast area. Its composition was also surprising. Fishing nets accounted for 46% of the mass, and between 75% and 86% of the plastic originated from offshore fishing activities. The first prototype tests soon revealed serious problems, ranging from leaking air chambers to failed anchoring systems, demonstrating that the original concept required a far higher level of engineering than anticipated. In response to these challenges, the idea of a 100-kilometer seabed anchored barrier was abandoned and replaced with free-floating systems approximately 2 kilometers long, using deep-sea anchors. System 001, nicknamed Wilson, was deployed in 2018 amid high expectations. However, the system quickly exposed major limitations. It failed to maintain an appropriate speed relative to the plastic, allowing debris to flow in and then drift back out. By the end of 2018, an 18-meter section broke due to material fatigue at welded joints, forcing the system to be towed back to Hawaii after collecting only about 2,000 kilograms of plastic over 4 months. Media coverage turned critical, and a 2018 survey found that not a single ocean plastic expert fully supported the project, with more than 25% considering it a bad idea. Slat described this failure as an unplanned learning opportunity. The team returned to the drawing board and identified the core issue. The system needed to move more slowly than the plastic in order to retain it. From this insight, System 001B was developed, much smaller and equipped with a parachute anchor to create drag. When launched in 2019, this system, for the first time in history, successfully captured and retained plastic from the Great Pacific Garbage Patch, including microplastics as small as 1 millimeter. This marked the moment of transition from theory to real-world proof. In the same year, the Ocean Cleanup announced a new initiative based on research showing that just 1,000 rivers, about 1% of the world's rivers, are responsible for 80% of the plastic entering the ocean. This discovery changed the nature of the problem. Instead of focusing solely on cleaning up plastic that had already drifted into the ocean and dispersed across millions of square kilometers, the organization shifted to a strategy of intercepting plastic at highly concentrated entry points, where river flow dynamics and geometry allow for far more energy and cost-efficient intervention. From this logic, the interceptor system was developed as an automated river-based plastic collection platform. Technically, the interceptor is a floating system anchored to the riverbank, with a guiding barrier placed diagonally across the current to harness the river's own kinetic energy. This barrier does not completely block the flow of water, but instead creates a guiding trajectory that gradually forces floating debris toward the collection mouth. As debris enters the body of the interceptor, a stainless steel conveyor belt continuously lifts the material out of the water, reducing prolonged water contact to limit wear and clogging. A single interceptor, operating fully autonomously 24/7 on solar power, can collect between 50,000 and 100,000 kilograms of plastic per day, shifting the focus from cleaning up consequences to stopping pollution at the source. From 2021 onward, the ocean cleanup began scaling up by deploying larger and more flexible systems, including versions with active propulsion, enabling more effective collection under a wider range of conditions. In parallel, fundraising campaigns such as Team C's provided the resources needed to accelerate the path from design to deployment, and by 2024, the organization had removed more than 15 million kilograms of plastic, with single-night collection efforts reaching up to 1.4 million kilograms, demonstrating that the scale of intervention had moved far beyond the experimental stage. But as the pace of collection reached unprecedented levels, an unavoidable question began to emerge. Where do millions of kilograms of waste go once they are lifted from the water? And what is their true fate? Waste collected is not simply retrieved and discarded, but enters a processing chain designed to permanently end plastic's life cycle in the natural environment. Immediately after collection, materials are carefully sorted by type, degree of degradation, and recyclability. Plastic that remains of sufficient quality is cleaned and recycled, not as a symbolic gesture, but as a way to make full use of what the ocean still allows humanity to recover. However, around 80% of the plastic has been degraded and contaminated to the point of being non-recyclable, and is therefore treated through energy recovery or processed within strictly controlled systems to remove it permanently from the environment. In every case, the guiding principle remains unchanged. The goal is not simply to dispose of the waste, but to eliminate plastic decisively, so that the ocean never has to bear the same kind of pollution again. Despite clear quantitative results, scientific debate surrounding the ocean cleanup continues, because this is not merely an engineering project, but a direct intervention in an open and complex ecosystem. One line of argument holds that ocean cleanup efforts primarily address the symptoms of the problem, while the root cause lies in the continuously rising rate of global plastic production and consumption. Another line of criticism focuses on ecological impacts, arguing that surface plastic accumulation zones are also habitats for new stonic communities, and that large-scale collection could result in bycatch. In fact, these zones are their home. The ocean cleanup has responded with field data showing that 99.9% of collected material is plastic and only 0.1% consists of accompanying organisms. Along with independent assessments concluding that the risk posed by plastic to ecosystems far outweighs the risk posed by cleanup operations. By the end of 2025, the ocean cleanup had removed more than 45 million kilograms of plastic, operated 20 interceptors in 9 countries, and employed over 150 staff from 30 different nations. The estimated cost to fully clean the Great Pacific Garbage Patch is $7.5 billion USD over 10 years, and the goal remains unchanged, to remove 90% of floating ocean plastic by 2040. From a teenager standing before plastic bags in the Mediterranean, humanity has now, for the first time in history, truly begun to address ocean pollution at scale, demonstrating that what was once considered impossible is sometimes merely a problem that has not yet been approached with the right mental framework.